Model Engineering for Beginners, Part 19, Common Threads Explained. So many people have asked me to do a video about threads, so here it is. Every workshop needs a lot of these. These are taps and dies, and this is my collection, or part of my collection that I've amassed over the years. Recently I've fitted a lot of them into die holders to speed the job up. I also have some ancillary equipment that I use with the taps and dies. These are tap wrenches, and this is an old and very rusty tailstock die holder, and it's next to a tub of equally rusty old dies. I have a lot more taps and dies than this, and believe me, you do need a few. Here is a common ME type thread. ME stands for Model Engineering in this case, and this is a safety valve, and it has a 1/2 inch diameter thread. In this clip I'm trying to find out what the thread is, so I'm very carefully trying to screw it into different dies, and so far it's not fitting in any of them. Luckily, ready to go in one of my die holders is the correct size die. This die is 1/2 inch by 26 threads per inch, a very common thread for locomotive type safety valves. This is what's called an express type safety valve, and it has a smaller thread on it. And to find the size of this, I'm applying the same technique. I'm just using a random collection of dies out of my box of dies until I find one that fits, but in this case none of them fitted. And that's because I thought this was a 3/8 of an inch diameter thread, but it isn't, it's smaller than that. This is a 7/16 of an inch thread, and another way of finding out what the thread pitch is to hold it against the tap. As you can see, it perfectly matches this 7/16 tap, and in this clip you can see the diameter and threads per inch marked on the die. So this one is 7/16 by 26 threads per inch, and it's a BSB die. Sometimes it gets a bit confusing. This is still an ME type thread because it's frequently used in model engineering, and the BSB stands for British Standard Brass as far as I'm aware. After a while you learn to spot the thread forms just by looking at them. I can clearly see that the thread on this small safety valve is 1/4 by 40 threads per inch, and this is very common for quite a lot of union nuts and quite a lot of parts that are found in steam locomotives. And by holding this very fine thread against a slightly coarser tap, you can see that it's nowhere near. When I select the correct size tap, you can clearly see that the threads are the same. As I've just mentioned, 1/4 by 40 threads per inch is commonly used in steam locomotive parts, but sometimes the threads can be 1/4 by 32 threads per inch, as used by Stuart models, Cheddar models and others. This is a Stuart model steam tap of a Stuart 504 boiler, and this thread is 3/8 by 26 threads per inch. And the problem is with these small threads is sometimes the nuts screw onto the threaded part, but only so far, which generally means that the pitch is wrong. When I check the threads on this nut using a 26 threads per inch tap, everything's fine, so there's nothing wrong with the nut, it must be the other part on the valve. So I'm checking that with a 26 threads per inch die. And this die goes on the thread okay. It tightens up slightly as I rotate it, but that's because the thread is damaged, so by rotating it all the way it's cleaning up the thread, and I would think that when I've done this the nut should fit alright. So now the nut fits the thread on the steam valve perfectly. I notice that this valve has an adapter. This is not standard, and the thread is not 3/8 by 26 threads per inch because this 3/8 by 26 threads per inch nut only engages a couple of threads and then tightens up. This ended up being a 3/8 BSP thread, which is 28 threads per inch as far as I can remember, so I thought I would write BSP on the valve so there can be no mistake when I come to fit this valve into a boiler. And BSP stands for British Standard Pipe, and this is called a 1/8 BSP thread, even though the thread diameter is 3/8 of an inch. With BSP threads, the 1/8 refers to the hole down the centre of the valve. It's very confusing. And some BSP threads are tapered, which makes it even more difficult to figure them out. You do find BSP threads on very old model steam engines and larger ones. But the most common threads that we use these days are just ME threads, model engineering threads. This thread's a bit peculiar, it's undersized. This thread is part of an old Stuart model safety valve, and it's definitely a little bit undersized. And the thread on Stuart model safety valves is generally speaking 5/16 by 26 threads per inch. So there is a bit of a pattern emerging here. Safety valves are often threaded using 26 threads per inch. But don't take it for granted. This is a 5/16 by 32 commercially available boiler bush, and if someone had built a boiler and used this for the safety valve, then it would be 32 threads per inch and not 26. Here's a small collection of very popular sizes of union nuts and union cones. These cones used to be called nipples, but I stopped referring to them as such because some viewers got a bit overexcited and started writing in, making very strange comments. As I mentioned at the beginning of this section, these are three very popular sizes: 1/4 by 40, 5/16 by 32, and 3/8 by 32. And using the wonders of modern technology, I've written the sizes on the bench using a felt tip pen. And as you can see, a 1/4 by 40 threads per inch union nut will accommodate a 1/8 pipe or a 5/32 pipe union cone. These cone sizes also fit 1/4 by 32 threads per inch nuts. And for the next pipe size up, which is 3/16 of an inch diameter pipe, the union cone for this fits in a 5/16 by 32 threads per inch union nut. And the next one up, 1/4 inch pipe. This fits into a 1/4 inch diameter union cone, which in turn would be held to the fitting using a 3/8 by 32 threads per inch union nut, or a 26 threads per inch union nut, or even maybe a 1/4 BSP union nut. This is the lower part of a water gauge fitting, and this uses a 3/16 by 40 union nut with a suitable cone to hold a 5/32 pipe. The other end of this fitting is a bit of a mess. What someone's done is rethreaded it 1/4 by 32 threads per inch when it was originally 1/4 by 40. Try not to do this because the resultant thread would be very weak. Here's another type of water gauge fitting. This one's 5/16 by 32. And here's a globe valve, 1/4 by 40, and another Stewart valve with an adapter fitted. But just look at the state of this one. You must never do this. It's a really easy option and it's a complete cop-out because the thread will fit either 1/4 by 32 or 1/4 by 40, but not very well, and it's really bad practice. This is another early Stewart Models valve, and once again, as usual, this is threaded 26 threads per inch. The original Stewart valves did not have a fitting that screwed into the boiler. The normal practice was to use a stainless steel adapter that screwed into the boiler and into the fitting, which was a good idea. This is a short section showing some of the tools that are used to cut threads in pieces of metal. This is called a tap wrench, and here's another different type of tap wrench. These are the ones that are used for small taps. This is the larger one of the two, suitable for up to 1/4 by 40. This is the same design of tap wrench, but it's much smaller, ideal for the smaller ME sizes or BA threads. Sometimes I use this old thing. I don't know where it came from, and it's only suitable for 5/16 taps, but it's quite good because it has a ratchet. I also have some of these. These just come along in boxes of bits now and again. They're called apprentice pieces. They were made by apprentices in the engineering industry many years ago, and sometimes they can be useful. I often use these. They are simple tap guides, but very useful for holding the tap in the correct position so it enters the hole squarely. If you start to thread a hole in a piece of metal and don't get the tap square, the deeper the tap gets into the hole, the more off-center it becomes and it can break. I showed how to make one of these, I think, in the workshop series. The largest die that I own is this one. It's a 5/8 by 26 BSB, British Standard Brass. Although I think this one's bigger, but I never use it. I don't know where it came from a car boot sale probably. And there's nothing wrong with car boot sales and jumble sales in general. I mean, where else can you buy a pot of dies that you never use? Most of them are so rusty you can't read what the thread size is anyway. I hope that you've found this entertaining, if nothing else. There's a lot more information about taps and dies on the internet, and if you want some more information generally, there is an e-book that I put together a few years ago, and that's available for my Patreon supporters to download for free. This is quite near the end of the video, and scrolling up the screen in Star Wars fashion is a list of very popular taps and die sizes. The golden rule for threading model engineering parts is not to apply too much pressure, and back off the tap frequently to clear the chippings. Also, don't forget to use tapping lubricants. Have a look at tapping lubricants. There are different ones for different types of metal, but I generally use my steam oil rapeseed oil mixture, which seems to work very well for me. I get quite a lot of comments from viewers, but one thing that has caused me a problem is that viewers ask me questions without watching any of the other videos. So if I don't reply to your question, the answer really is watch some more videos. Please be aware that there are currently over 1,000 videos covering many topics to do with model engineering. Originally I started making the videos just to put something back, and the problem was when I was a beginner I found it very hard to get the correct information. But now, thanks to the internet, here is the information for everyone to see. And if you're a beginner to model engineering, you could do worse than watch the series called Model Engineering for Beginners, and this is part 19 of that series. Probably a good idea to watch the other 18 episodes as well. And that's about it for this video. From me, in a workshop far away, thanks for watching and I hope you found it useful.